Hello, welcome to online version of Physics 103. So in this video, we'll be talking about electric charge and electric field. As you know, an atom consists of electron, proton, and neutron, right? Proton has positive charge, electron has negative charge, and neutron has no charge, right? Let's begin with the electron. The electronic charge is the smallest possible charge. That's why we call it fundamental charge. So in 1 coulomb of charge, we have that many electrons, 6.25 10 to the 18 electrons. Okay, that's a lot of electrons. So 1 coulomb is a really big quantity. Now let's talk about the property of charge now. Suppose we have charged particle or any object that is charged. You have a rubber pen, right? You have a pen, and if you rub your pen plastic rod or something on the head, then that will be charged, right? So that's what I meant by charged object, any charged object, right? So suppose there are two kinds of charges, right? Suppose you have plus and minus charges together like this. Suppose this is plus charge, this is minus charge. So if they are near to each other, then what happens? They attract. Okay. If there are dissimilar charge, meaning minus minus or plus plus, either one, minus minus, they repel, plus plus, they repel also. But if you have dissimilar, if you have dissimilar charge, there is attraction. If there is similar charge, I should have said similar charge here. Similar charge repel and dissimilar charge attract. That's the property of charge. Okay, an object can have a charge. Could be positive charge or negative charge. Not only that, those charge can move from one object to the other object. Like heat moves from hot object to the cold, right? So hotter to cooler, right? So in this case, if we take a look at this picture here, this is hot, red hot, and this is cold, right? What happens is if they are in contact, if the hot and cold, these objects are in contact to each other, then what happens is the heat goes from hot to cold, right? Hotter object to the cooler object. In the same way, if you have two objects, one is negatively charged like this, the other one is positively charged, then what happens is that the electron will move from negative charge object to positive charge object. The same way the heat does here. Okay, the heat is analogous to electron. Okay, the substance that readily conduct electric charge are called electrical conductors. Not all the objects are electrical conductors. Some of them are electrical conductor, some of them are insulator. Okay, so which can conduct electricity easily, meaning the charge can go from one part of the object to the other part of the object. Suppose this is an object. And you have charge in here. If you place the charge in here, then this charge can move to the other end easily from here to here. Charge can move. If the charge can move, then that kind of object or substance is called electrical conductor. If the charge cannot move, right, that's called insulator. Now let's talk about now we said that there is a force between charged particle. So what is the nature of the force? If the charged particles are dissimilar, there is attraction. If the charged particles are similar, then there is repulsion, right? So whatever you call it, repulsion or attraction, there are two kinds of force there, right? Repulsive force and attractive force. So whatever the nature of the force be, in other words, whether it is negative, repulsive or attractive, it doesn't matter. But that force is always dependent on the product of these two charges here. Okay, so bigger the product of these two charges, bigger this force. In the same way, bigger the product of these two charges, bigger this force. Okay, that's what it meant. That's what I meant. So meaning bigger this guy, bigger this charge, then you have bigger force. Bigger this charge, then you have bigger force. In other words, when this and this are big, then the product also big, right? That's what I meant. Okay, product of, let's say this is 3, this is 4. What is the product? Product is 12, right? Okay, so bigger the charges, bigger the product, and bigger the force. Okay, in the case of plus and minus, the force is attractive. In the case of plus and plus, the force is repulsive. So here the big attractive, here big repulsive. If the product of charge is big. For the bigger product, you have bigger force. Now what happens if you separate them further? Means if the charges are separated and more distance further, then the force goes on decreasing. On the other hand, if they come closer, then the force becomes stronger and stronger. So it means it depends on, this is how it depends. So it depends on the distance between the charges. Actually, it depends on the square of the distance between the charges. Okay, R square. It does not simply does not depend on R, but R times R. So if you combine all of this, then you can get force equals K times Q1 Q2 times R square. So bigger the Q's, bigger the force. Smaller the R, bigger the force. R means the distance between the charges here. And this K is called constant. Okay, this is the constant. If you have those charge particles here, so this Q1 and Q2, they are two charge particles. If these charge particles are in vacuum, in the air, okay, in air medium, meaning they're simply placed like this in air, then that this K happens to be equal to this quantity here. See, this K has the value, this is constant, it has the value of, I can simply call it 9.9 over 10 to the 9. If I round it off, right, 8.99, I can simply call it 9. 9, 10 to the 9. It's easy to remember also. 9 and 9. 9, 10 to the 9. Actually, that K depends on, the K is defined by this relationship here. This K is 1 over 4 pi. You know, pi is number, 3.114. Then, do you see this something like E here? E and sub-zero. Okay, this is called epsilon, and this has the value of 8.85 10 to the negative 12. Okay, when you divide 1 by 4 by epsilon 0, then you happen to get this. So this is called epsilon. Let me write this down. EP SI L ON. So epsilon 0. So epsilon then 0. Okay, looks like E, but we call it epsilon. Okay, and we have the name given to this guy. So epsilon is named as permittivity of free space. PERMITTIVITY. Permittivity of free space. Okay, that's the name given to this epsilon 0. Okay, now let's find the velocity of the electron moving around the nucleus, because in the atom, right, so there are, what are the particles do you have inside the atoms? You have neutrons, proton, and electron, right? So in the center, let's say this is proton. There is also neutron, but neutron does not have charge. So that's why there is E plus no charge, something plus 0, something, right? Okay, that's why you don't have to take the neutron into account. You simply say it has proton, and proton is revolved by the electron, or electron goes around the proton in this way, in this circle. Okay, so of course this is proton plus neutron, but the neutron does not have charge. That's why we simply call it proton, charge of the proton only here, because we are talking about charge only, right? Okay, we're just talking about the force related to charge, not anything else. Okay, so in the center you have plus E, which is charge of the proton, and electron goes around the proton. Now you are supposed to find, you are asked to find the velocity of the electron here. What is the velocity of the electron in this case? That's why you need to figure out. Okay, let's find the force first. Okay, what is the force between these two electron, this proton and electron? Let's find the force. Okay, so we have the formula, right? Force equals K times Q1 Q2 over R square. What is K? K is 9 10 to the 9, or if you want to write explicitly the exact form, 8.99 10 to the 9. That's my K. Now what is Q1? So you can call this is Q1 or this is Q2. Oh, by the way, I forgot to mention here. So remember you have bar here. Do you see the bar for the charges here? There are vertical bars. What does that mean? That means don't worry about the sign of the charge. Okay, we just care about just the magnitude of the charge. So that sign, we don't want to talk about sign, because what is the role of the sign? If there are different sign, then
Different
what is the force?
directions?
Excuse me?
Do they mean, when you say different signs, do you mean different directions?
No. In this case, yeah, that's a very good question. But when it comes to the electric field, so electric charge, now we are talking about different charge here.
Oh, okay.
In mechanics, you're right. We're talking about plus and minus direction, right? Now here we're talking about plus and minus charge. So when you have plus and minus charge, as here, right? Plus E and minus E. So what is the force between this guy? What is the nature? I'm not talking about the number. What is the nature of the force? Is the force attractive or repulsive?
Attractive?
It's attractive force, right? Because the similar charge repel and dissimilar charge attract. We have plus and minus, dissimilar, that's why they attract. So you don't have to worry about the sign, just take the value only. That's what this formula says. This formula says just take the value of Q1 and value of magnitude only. Take the magnitude of Q1 and Q2. Don't worry about the sign. Because from the sign, we can figure out the nature of the force itself. We don't have to worry about the sign. Because if you have different sign, then there is attractive force anyway. So don't worry about the sign. We'll know how to figure this out. We know how to figure that out. So in the formula, that's why we don't have the sign here. Just the magnitude of the charge. So Q1, what is the magnitude of the charge of the proton? So by the way, the charge on the proton and charge on the electron are there exactly equal, but opposite. Okay, so what is that's constant, right? I'll give this constant here. Electronic charge and proton charge, they're exactly same in magnitude. Only difference is proton has plus, electron has minus. But in this formula, we don't care about the plus and minus, because formula says don't worry about the plus and minus. Just take the value only. That's what my formula says. Then what is the distance between this electron and proton? So this is also number I give it to you. I give you all the numbers. Don't worry about the numbers, okay? So then if you calculate that, the force happens to with this one here, 8, 10 to the negative 8, which is very, very small, right? Negative 8 means very small force. So what is the nature of the force? This is the magnitude of the force. Magnitude of the force. And what is the direction of the force? Since this is attractive, the force is, the electron is attracted towards the center. That's how you figure out the direction. Force is directed out towards the center. Now, when something moves in a circle, there should be a force directed towards the center, right? You know that, right? When something moves in a circle, there should be a force that is directed towards the center. What is that force called? Guys, anyone help me?
Centripetal force.
Exactly, centripetal force, right? Now remember this force is, this force, right, which we figured this out, this is directed to the center, okay? And we already know that there should be a force directed to the center because this is moving in a circle. Then can I say that this force is centripetal force? This force happens to be centripetal force. This is the coulomb force. We know this is the coulomb force, and this coulomb force act as centripetal force. Okay, now this force is centripetal force, meaning centripetal force is given by mv square over r. So that mv square by r equals to F. So F is this guy. F is exactly this guy here. This is my F. Then do you know the mass of the electron? So what is moving? Electron is moving. This guy is moving. That's why I have to take the mass of the electron here, not the proton. You have to take the mass of the particle that is moving. Okay? This m is the mass of the particle that is moving. In my case, electron is moving. So this is mass of the electron. So what is R? R is distance between these two guys. And we already know that, right? 5.29, 10 to the negative 11. That's the R. So how many equations? One equation, one unknown. Can you figure out V from here? Because V equals, so multiply both sides by R, you got mv square equals F times R. Then divide by M, you get Fr over M. Then you have V square here, that's why you just take the square root. That's your V. You need to figure out the V. That's your final goal. Now you know F. F is exactly this guy here. F is this guy. This guy is F. Then R is this guy here. That's what it is. This is your R. Then what is the M? Mass of the electron. I'll give this to you. Okay, mass of the electron is constant, and I'll provide it to you in the test. So which is 9.1 10 to the negative 31. So if you can do the calculation, you happen to get the velocity of the electron to be 2.18 10 to the 6 meter per second. Is this small velocity or big? This is very big. Because what is the velocity of light? Light is 310 to the 8, right? Okay. And this is only 100 times less than the velocity of light. This is only 100 times less than velocity of light. So this is much faster than everyday life, in our everyday life, like car, train. So whatever you name it, it is much faster than that because it is only 100 times less than velocity of light. So this is how fast electrons moves in a atom. In the atomic model, we have electrons and proton, right, and neutron, and electron goes around the nucleus. So this is how fast the electron move. All right. Now let's talk about the charge on force on 3 charges here. Now determine the magnitude and direction of the net force on Q1. So there are 3 charges here. I'll call Q1, Q2, and Q3. And all of them are given. Q1 is 3 microcoulomb. What is micro? Micro is 10 to the minus 6, negative 6 meter, a coulomb, okay? Micro is 10 to the negative 6. Okay, so you have to convert into coulomb, okay? You remember you have to do in the SI system or metric system. So this is 3 10 to the negative 6 coulomb. This is negative 7 10 to the negative 6 coulomb. And this is negative 4 10 to the negative 6 coulomb. So what is the separation between these two guys? They are separated by this amount, 0.2 meter, and these two are separated by 0.15 meter. Now, what is your goal? Your goal is to determine the magnitude and direction of the net force on Q1. Q1 is this guy here, Q1. This is my Q2. This is my Q3. Q3 is negative 7 10 to the negative 6 minus 6 coulomb. And Q1 is 3 10 to the minus 6 coulomb. And Q2 is negative 4 10 to the minus 6 coulomb. And the distance between these two guys is 0.2 meter. And distance between these two guys is 0.15 meter. Now your goal is to figure out the magnitude and direction of this force on Q1, force on Q1. Force on Q1. So force on Q1 due to what? Due to Q2 and Q3. Force on Q1 due to Q2 and Q3. Okay, so meaning force between Q1 and Q2 and force between Q1 and Q3. That's what I meant. So what is the force between Q1 and Q2? And Q1 and Q3. Let's do that. So what is the force here? This force is, let me call 1, 2, F12, and let me call this force to be F13. What is F12? What is the formula for force? Force equals K times magnitude of Q1, magnitude of Q2 divided by R square. That's the formula, right? What is K? For simplicity, I put 9 10 to the 9. Okay, what is that? That is K. What is your Q1? 3 10 to the negative 6. What is your Q2?
4 to x to the negative 6. Oh, 4 to the negative 6.
4 10 to the negative 6. You don't have to take care, you don't have to worry about this minus sign, right? Because in the formula it says, just worry about the magnitude. Don't worry about the sign. That's what it says. Divide by, what is your R squared? 0.2 squared. That's your F12. What is your F13? 9 10 to the 9. 3 10 to the minus 6. Then Q3. Now Q3 is 7. You just take the magnitude, which is negative 7. So magnitude is just 7. So 10 to the negative 6 coulomb divided by, what is distance here? Q1 and Q3.
0.15 squared.
Yep, 0.15 squared. Very good. Thank you. So now what is this force? This force is, what is the magnitude of this force? F12, if I calculate F12 in the calculator, I happen to get 2.7 Newton. If I do F13 in the calculator, then I happen to get 8.4 Newton. Okay. Now let's talk about the direction. Now we know the magnitude, right? We know the magnitude of the force. Now what is the direction of these forces? What is the F12? Let me make the diagram here again. So your Q1 is here. Your Q2 is here. So what is the direction of force on Q1 due to Q2? On 1 due to 2. On 1 due to 2. what is the direction? Right or left?
Right.
Because Q1 has positive charge, right?
Mm-hmm.
And Q2 has negative charge.
So it would be left.
So remember, this Q2 does not move, just Q1 moves. Because we're going to find the force on one. On one. That's why this guy moves. Q2 does not move. Keep that in mind. This is very, very important, okay? On one, meaning the charge one will move. Okay, so if I make mistake, you have to be able to correct me, okay? When I say on one, means that guy will move. On means move. On one, okay? So Q1, force on Q1 due to 2, means this Q1 will move. Does it move to the left or right?
The left.
Left, because the plus and minus attract. That's why it's going towards that one. That's your F12. Now, what is the next one? On 1 due to 3 now. Force on 1 due to 3, not 2. 2 is already done. Force on 1 due to 3. So your 3 is here. There is Q3 is here. So will the 1 goes to 3 or 3 comes towards 1? Or, by the way, what is this? Q3 is negative, right?
Mm-hmm.
So what happens between these two plus and minus? Attraction or repulsion?
Attraction.
So meaning, will the Q1 moves or Q3 move?
The Q1 will move.
Yeah, Q1 moves all the time. Whatever you say on, right? Force on Q1 due to Q3. That's why this Q1 moves, because of the attraction. Meaning Q1 and Q3 attract to each other because plus and minus attract. And here plus and minus also attract. That's why Q1 is moving towards the Q2. This is F13. I want you guys understand. This is very, very important. So F12 is directed towards the left. F13 is directed towards the right. What is your F13? F13 is 8.4. What is your F12?
2.7.
2.7. So now you call which direction is positive. Do you want to call the right positive or left positive?
The right positive.
So right is plus 8.5, left is
Minus.
so what is the net force now? Plus 8.4 minus 2.7.
Mm.
That's your net force. So what do you get? 5.7. That's your net force.
Does it matter which number is positive or negative? Like if instead of 8.4 being positive, could it be negative?
Yeah, you can say negative, but then your answer will be negative here.
Okay.
So when you say this is negative, right? So what you are saying is your negative is towards right.
Uh-huh.
Okay. Then what is the net force? Net force will also negative, meaning your net force is towards right. You get the same sense anyways.
Mm.
Okay.
Okay.
So it doesn't matter. Let me ask you a question here. So you have 3 charges here. Charge 1 coulomb. What is 1 coulomb? 1 coulomb is here. Let me write this. This is triangle, right? This is the triangle. So 1 coulomb is here. 2 coulomb is here. And 3 coulomb is here. By the way, this is -3, right? Now, what is the direction of force on the 1 coulomb charge? Not the magnitude, okay? You don't worry about the magnitude. I'm not going to ask you. Just the direction of force on 1 coulomb charge. On 1 coulomb. Remember, on. So when I say on, that charge will move, right? Other two doesn't move. Other two don't move. This plus 2 and plus minus 3 don't move. Because I'm asking you net force on. That's why this plus 1 charge will move. How does it move? Let's figure this out. Okay. What is the force between these two? Force due to this guy on this. What is the direction of force? Away from 2 coulomb or towards the 2 coulomb? Is it away or towards 2 coulomb charge? Meaning, if this force due to plus 2 on plus 1 coulomb, is it towards 2 coulomb or away from 2 coulomb? It's away from 2 coulomb, right? It's like this. That's the force. Why? Because this is plus and this is plus. What happens between plus and plus? Attraction, repulsion?
Repulsion.
That's why this plus 1 wants to go away from this plus 2. Repulsion meaning this plus 1 wants to go away from plus 2. That's why this is the direction of the force due to plus 2 on plus 1. Does it make sense so far? Then how about here? How about the force on 1 coulomb due to negative 3 coulomb? So what is the nature of the charge here? This is plus, this is minus. On 1 coulomb, this guy will move, right? Plus 1 will move. So will that move towards negative 3, minus 3 coulomb? So is it like this? Is this go away like this or comes towards the negative 3? That's what I'm saying. It's upward or downward?
Downward.
Downward.
Downward, because this plus 1 will move, right? Plus 1 will move. How does it move? Because this plus and minus, are they attractive or repulsive?
Attraction.
Attraction. That's why this plus 1 will move towards minus 3 because minus 3 is attracting that plus 1. Okay, now what is our goal? Our goal is, what is the direction of the net force? So we know the force, right? Force is, one force is this one, other force is this one. So what is the net force?
F2 plus F negative 3.
Yeah, but it's not like, it's like vector, right? So if you have some, let's say if you have an object here, if you have an object and if you pull, let's say in 2 directions like this, 2 people are pulling this, where does this go? If you pull this by 2 people here, this way on the right and downward, where does this guy, will this go to the right or will it go to down? Somewhere in between, like this. Does it make sense?
Yep.
That's the direction of net force. Net effect. Net effect is that. So that's why when you have force like this, F2 and F3, then the net force is goes somewhere in this way, in this direction. So we find the direction of the net force. That's what we are supposed to find, direction of net force. I'm not asking you to find the magnitude, how much force, I don't care. But what is the direction of the force? Of course, you can find the magnitude also, but I'm not going to do it now.
Is the force Like if the -3 was higher, like if it was -10, would the direction be more toward that direction?
Yeah, you're right. Because let's say this is like let's say 10 Newton, right? This is say 1 Newton, right? I think this is what you are asking.
Yeah.
If this is the case, then the direction will be very, very near to 10 Newton.
Okay.
Let's say this is 100 instead of 1. If this is 100 Newton, then this direction will be very, very near to 100 Newton. Okay, let's talk about electric field now. So for the electric field, also the force. Remember, I always talk in the class, like in $5 you get 10 mangoes, right? You get 10 mangoes. In $1, how many mangoes do you get? It's that kind of problem, okay? So here, let's say, before I jump in here, let me tell you what this picture is telling us. Okay, there are 3 charges here. Let's say this is plus charge. We have plus here, we have plus charge here, and we have also plus charge here. We have 3 plus charges which are blue, and also, okay, this is, let's say this is also plus charge. Then what happens between these 2 guys? Is there repulsion or attraction? Between these 3 charges, I'm talking in total, okay, total of these 3 charges. What is the effect of these 3 charges on this plus charge? Will the force be repulsive or attractive?
Repulsive.
Repulsive, right? So that's what I'm showing. The force is repulsive, meaning it's going away, right? That's what it means. Okay, going away. Now, that force, suppose we don't know the amount of charge here, right? See, we call it test charge. By the way, this is called source charge. Okay, this is source charge. There are 3 source charges, and there is only 1 test charge. Okay, let's say this is equivalent to 5. Let's say, so this is, let's say, 5 coulomb. Okay, then what is the force between these 2 guys? I don't know the charge on this guy. I don't know how much is this guy here. I don't know the charge of on this, so I don't care the total charge. Maybe 15 coulomb here. I don't care. Okay, so force between these 2 guys, let's say, is 10. I don't know. It's just a number. Okay, let's say force between these 2 guys is 10. Okay, suppose you have plus 1 charge here. Suppose here we have 5 plus 5 coulomb, right? Suppose you had plus 1 coulomb charge. How much will be this force? Did you guys understand my question?
Not really.
Okay, so I gave you 2 things here. So the force between these 2, remember this charge and the red. Force between 3 blue charges and red charges. Force between these 2. What is the force between these 2? 10. And you are given this Q here. What is this red charge? Red charge is 5 coulomb. So what I'm saying is force on 5 coulomb charge is 10 Newton. Then what is the force on 1 coulomb charge? Suppose you replace this 5 by 1. Remember? You replace this 5 by 1 coulomb. Then what will be the force on this 1 coulomb charge?
2.
2, exactly. Okay? It's like in $5 you get 10 mangoes, in $1 how many mango you get?
2.
Exactly like that. So
Oh,
does it make sense?
yes.
So the force between these 2 is 10, assuming this is 5 coulomb. If we had 1 coulomb here, the force will be 10 over 5, which is 2. That's called force per unit charge. That's what I call is force per unit charge. How do you find the force per unit charge? You divide the force by the amount of charge. See, in our case, 10 divided by 5. Okay, F is 10 and Q is 5. By the way, this is 5. Okay, sorry about this crazy 5. This is 5. So that's that quantity. When you divide force by the test charge, that quantity is named as electric field. This guy is now named. What is the name of this guy? Name of this guy is
Electric field.
electric field. And electric field is the force per unit charge. Electric field is defined as force per unit charge. That is force divided by Q test charge. So by the way, this test charge sometimes can be written as, is also written as Q sub 0. Instead of writing test, you simply write Q0. So that's the formula for electric field. Okay, what is the unit of electric field then? What do you think the unit of electric field? Excuse me? Electric field is Newton per coulomb. See, because force in Newton. So what is Q? Q is
Coulomb.
coulomb. So that's why it's Newton per coulomb. So now if you plug in the value of F, right, what is F? F is this. We already know that, Coulomb law of force, right? That's your F. So plug in the value of F in here on the top and divide by Q0. What happens? This Q0 and this Q0 cancel out. Then what is the electric field then? K Q over R square. That's the formula for electric field now. Meaning, you don't worry about this charge here. You just worry about this Q. Because this is Q. This is Q0, right? This is Q0. This is Q and Q0. Because no matter what the charge is, you are going to find the 1 unit charge anyway, right? Because you divide by, because you have to make this 1 anyway, right? That's why it does not depend on this. It just depends on Q, this Q. Electric field just depends on this Q, not this Q. Because this Q has to be 1, plus 1 by the way. This Q0 is plus 1. Keep that in mind. Q0 is plus 1. Not minus 1, plus 1 all the time. No matter what the problem is plus 1. So in that case, your E equals K Q over R square. That's the electric field. Now, okay, let's do this problem here. 2 positive point charges. What is point charge? A charge which is located at a point, right? That's very easy. If you have, suppose this is a point, you put the charge on it, and we call it point charge, okay? 2 positive point charges, Q1 and Q2. This is Q1, this is Q2. Are separated in a vacuum or air. In that case, we know our K, right? When it is in air, we know our K. K is 9 10 to the 9. In vacuum, by a distance of 3 meters. They are separated by 3 meters here, total. This is 3 meters. Now, what are you supposed to find? Find the spot on the line between the charges. So this is the line between the charges, right? So find the spot on the line between the charges where the net electric field is 0. My P is somewhere between Q1 and Q2. So what is the charge you put on P? plus 1. Plus 1. Okay, don't worry about the unit, just plus 1. Unitless plus 1. Okay, don't worry about the plus. Oh, unit of this plus 1. You simply put plus 1. Okay, suppose you have minus charge here. You have minus charge here. Then also you put plus 1 here. No matter what the nature of the charge, Q1 and Q2, you always put plus 1 here. What is the electric field due to this guy on this guy here? Let's say that field due to Q1 on P. So this P will move, right? On P, which is plus 1. Plus 1 will move. Where does this guy move due to this plus charge? Towards the right or towards the left?
The right.
Yeah, the right, because this is plus, right? And at point P, you always put plus 1, no matter what. What is the force between this plus and plus? Repulsive or attractive? This and this. Repulsive. That's why this guy move away from Q1. So this is E1. This E1 is due to Q1. E1 is due to Q1. Meaning this Q1 will repel this plus 1 away from it. That's what E1 is, towards the right. Now how about the force due to Q2 on P? Is this repulsive or attractive?
Repulsive.
Repulsive, meaning it will go away from Q2, right? So due to Q2, the force on P is repulsive. That's why the P will go away from Q2, means this direction. That's your E2. So now you have E1 and E2. Now let me write this question, then we'll go from there. So you have plus Q1 P Q2. This is plus 1 no matter what. So force due to this guy on Q1 is towards right. Okay, this is called E1. Force due to this guy on Q, this P is towards left. This is E2. So now we have two forces like this, E1 and E2. E1 is towards the right, E2 is towards the left. Let's figure out E1 and E2. Then if E1 is plus, then E2 happens to be minus, then we'll add them together. Oh, you know what? If you add them together, what is the net force?
0.
0, exactly. So meaning E1 minus E2 equals 0. The net is 0, right? Meaning
Yeah.
E1 equals E2. Okay, this is the equation we have. Now we need to find E1 and E2, and you have to equate them. Let's figure out E1 now. So what is E1? So what is Q1? Q1 is 16 microcoulomb. 16 microcoulomb is 10 to the minus 6 coulomb. Then what is Q2? Q2 is 4 10 to the minus 6 coulomb. What is the formula for E? If you remember, KQ over R square. That's what we just proved, right? This is the formula. So for this guy, what is your K? K is 9 10 to the 9 again. What is your Q for E1? For E1, Q is Q1, right? What is your Q1? 16 10 to the negative 6. Then what is the R square? See, R square is here. What is your R square? We don't know. But you know what? We know the distance between these two guys, right? What is the distance between these two guys? If you remember, this is 3 meter, right? Let me make sure. Yeah, that's 3 meter. Let me say this distance is D. I'll call this distance D. From Q1 to P is D. Then what is my Q2 to P? From Q2 to P, how much is Q2 to P? Can I say 3 minus D?
Yes.
So because this is D, this should be 3 minus D. So that D plus 3 minus D is 3. Okay. Then what is the distance here? E1. What is the distance? D squared. Then what is E2? Again same formula, but Q is Q2. 9 10 to the 9. What is Q2? 4 10 to the negative 6 divided by what is D? What is the distance between Q2 and P?
3 minus D.
Exactly, 3 minus D. So these guys are equal. These guys are equal to each other. This left hand side equal to right hand side. So how many equation? One equation, one unknown. Unknown is D. One equation, one unknown. We can solve it. Let me share my window one more time. That is the PowerPoint. I think in this picture is more clear. By the way, this K is known, but if you divide both sides by K, right? If you divide both sides by K, then you get, they cancel each other, right? K is gone. So K cancel out, K cancel out. Then this negative 6, they cancel out, right? Then what are you left with? 16 divided by D squared, 4 divided by 3 minus D squared. So, so what are we left with? We are left with 16 divided by D squared equals 4 divided by 3 minus D squared. We are left with that, right? Okay. So if you divide both sides by 4, what do you get? 4 over D squared equals 1 over 3 minus D squared. So far so good?
Yeah.
So 4 3 minus D squared equals D squared.
Mm-hmm.
Yeah, you can simply take the plus minus square root on both sides. Okay, so you simply take plus minus square root like this. Then 2 3 minus D equals plus minus D. Because remember, if x equals 9, x square equals 9, what is your x? Plus minus 3.
Mm-hmm.
That's what I did. So if you take plus, then what do you get? Take plus, then take minus. Okay, let's do separately. When you take plus, then you get 2, 3 minus D equals D. When you take minus, you get
Negative D.
negative D. So what does this give me from the top? 6 minus 2D equals D. From here, what do you get? 6 minus
2D.
2D equals negative D. So if you take to the other side, what do you get? 3D.
And then 1D. And it's a negative.
And this is 6 equals 3D. Right? Then D equals 2. How about here?
This will be positive 1.
Yeah. So D equals 6. So you have two answers here. D equals 2, D equals 6. Wow. Now the thing is you have in trouble now. You're literally in trouble. You know why? You have two answers now. What do you do?
Choose one.
Yeah, choose one. So how do you do that? So you can see my screen now. Now you have to choose between 6 and 2. Now let's read the question again. While separated by vacuum, distance of 3. Find the spot between them. Whether between them. So what is the distance between them?
3 meters.
3 meters. So can your D, this is your D, can your D become 6?
Nope.
No.
Because it has to be in between, right? And the distance itself is 3, the total is 3. And this D has to be less than 3. There is no doubt about it.
Yep.
That's why you have to disregard 6. That's why your answer is 2. Does it make sense?
Yep.
So let's talk about the electric lines of force. Suppose you have plus Q charge here. You have minus Q charge here. Let me change my screen. Let me go back to my, yeah, you have plus and minus charge here. Okay. Now you take plus 1 charge. Remember, we always take plus 1. You take plus 1 charge. So if you put this plus 1 charge near to this plus 1, plus Q, where does this plus Q go? Does this go this way or does this go this way? Towards the right or towards the up, towards the top, towards the in upward direction or towards right?
Goes right.
Because this guy is repelling this plus 1. At the same time, this guy is attracting this plus 1. So this say go away. This says come to me. Okay. So this guy, that's why this will travel this path. If this plus 1 is here, how does this plus 1 travel? This will travel like this. Go directly that way. If the plus 1 is right here, how does this plus 1 travel? This will travel this way. If the plus 1 is here, how does this plus 1 travel? This way. Okay. So this path, this line is called electric lines of force. Let me discuss some of the property of electric lines of force. So each electric lines of force originate from positive charge and terminate to the negative charge. Meaning the force, this line of force always starts from plus charge and end at negative charge. Makes sense, right?
Yes.
So what is the number? So number 3, let me talk about number 3, then I'll talk about number 2. What is number 3? No two electric lines of force cross each other. That's interesting. See, there are lots of lines of force, but no two electric lines of force never cross each other. Then what is number 2? That's very important. Let me talk about that. That's very, very important. Okay, guys. So what number 2 tells me is a tangent. What you know what tangent means? A line. Let's say this is the point 1, right? I can draw the tangent right here at the point 1. So how does the tangent go? Does it go downward or does it go this way or upward? Upward, because you have to take the direction of plus 1 charge. So similarly, tangent at 2 will be this way. You know what tangent, right?
Yes.
So how do you define a tangent right here? Let's say this is the tangent. This is the point. How do you define the tangent? This is just the line passing through that single point only, 1 point only. That's called tangent. Okay. So I have tangent here at point 1. You have tangent here at point 2. What do those tangent indicate? That indicates the direction of electric field at that point. Look at that. That tangent indicates the direction of electric field at that point. So this is the direction of electric field at this point. So E1, see, is directed this way, where E1 is electric field at this point 1. How about E2? E2 is the electric field at point 2. So this is directed this way. So how about 3? Let's choose one more point here. How about 3? Let's choose this point here. How does the electric field orient? What is the direction of electric field at this point? Draw the tangent, and that tangent gives you the direction of electric field at that point, this point 3. Similarly, you can draw any tangent, meaning you can draw tangent at any point and find the direction of electric field at that point. Okay, let me repeat it. The tangent at any point on the electric lines of force indicate the direction of electric field. Now in this case, how many charges do you have? You have plus charge and minus charge. Okay, so now let's say you have just only one charge, right? Let's say plus charge only. How does the electric field look like? So that's what I meant by, that's what I'm trying to show you here. Okay, so let's say what I meant by that is, if you have plus 1 charge here, if you have the plus 1 charge right here, where did this go? This goes away. This will go this way. Okay, this will go this way. If you have plus 1 here, it will go this way. If you have plus 1 here, it will go this way. Okay, so that's what it means. So if you have single plus Q charge, then electric field lines due to this plus Q charge is away from the plus Q. So meaning if you have plus 1 here, it goes this way. That's how you understand. So that's what you have seen here. Now if you have minus charge, then how does the line go? Because no matter what, you put the plus 1 charge, right? So in the previous slide we have plus Q. You are talking about 2 charges here, plus Q and plus 1. Now in the next slide you are talking about minus Q and plus 1. It's always plus 1. You always take the plus 1 charge. Your test charge will be always plus 1. So keep that in mind. Your test charge is always plus 1 charge. If you have the test charge here, then how does it move? It goes towards the minus Q because they attract. So similarly, plus 1 is here, it goes this way. That's what the lines of force forces look like in the case of individual charge. In this case, minus Q, all the lines of force going towards minus Q. In this case, plus Q, all the lines of force going away from plus Q. Okay. Now, how about if you have plus and plus charge, plus Q and plus Q charge? Remember, we have plus Q and minus Q here. You simply have plus Q. You simply have minus Q. Now we are talking about plus Q and plus Q. If you have 2 charges like this, plus Q and plus Q, then how does the lines of force look like? Meaning, what do I mean by that is, if you put plus 1 charge near to those charges, what is the path of plus 1 charge look like? That's what I'm saying. So if you put plus 1 here, plus 1 charge here, then the plus 1 charge go this way, this route. If you put plus 1 charge here, then this plus 1 goes this way, goes away, because this plus 1 and this plus Q repel each other. Similarly, if you put the plus 1 here, it will go this way, because again there is repulsion due to this plus Q. Plus Q and plus 1 will repel. So similarly, you can plot all the lines here, electric field lines. And if you plot all the electric field lines, then your field in your diagram looks like this. So with this, I want to conclude this lecture, and I'll see you guys in the next lecture. And in the next lecture, we'll be talking about electric potential.